Hi folks, welcome to day 1 of section 9.5. Remember that this is an extra credit unit and each day must be completed along with that final test for 9.5 in order to get credit for the test, alright? So make sure that you do all of these days if you want to get credit for the test. So 9.5 is on something called the quadratic formula. All right, and we've been working with quadratics for a while now in trimester 3, right? And quadratics are always of the form ax squared plus bx plus c, right? And like that form might look a little different, but we're talking about just in standard form. All right, because it could be in vertex form, it could be in intercept form, etc. But the key piece here is identifying A, B, and C. All right? Now, this is something that some students have definitely struggled with, which is why we're going to review it today before we get into what the quadratic formula means. So if you had something like y equals 7x minus 2x squared plus 5, right? It's really important to put these in standard form by putting that x squared term first, and I'm going to always recommend that that's your first step, all right? So I'm going to write that in pink, that your first step is to put in standard form, all right? So if you haven't already done so, make sure you're trying that out now. So you should get that the standard form of our problem is y equals negative 2x squared plus 7x plus 5, all right? So that's our first step in quadratic formula problems, is just making sure things are in standard form. Then we're going to identify our A, our B, and our C. So our A looks like it's negative 2, our B is positive 7, and our C is 5. It's really important that we actually identify our A, B, and C because we're going to need them in what is the quadratic formula. All right, so I wanted to review this piece of quadratics first because when we're working with the quadratic formula, all right, I'm going to abbreviate it QF. What you're trying to do is you're trying to find your x-intercepts, all right? So you're trying to find where your graph, which I have in red, crosses the x-axis. You're trying to find those 2 points, right? And like those were your P and Q from intercept form of quadratics from our previous chapter, right? So this is kind of like a fundamental thing in math, that basically, if you have a formula, right, sometimes the only thing you need to know is where it crosses the x-axis, right? And that's what we call our x-intercepts. But it's difficult to just look at a formula and just know what the x-intercepts are. It's also difficult to graph, as you have all seen, right? So it's actually easiest. The easiest way to find x-intercepts is to use the quadratic formula. Now, the quadratic formula says, all right, if you have something that looks like y equals ax squared plus bx plus c, well, since this is our x-axis and that's our y-axis, we're trying to see these 2 points, all right? So we know up here, right, maybe this is like y equals 5, and maybe up here we have like y equals 10. Well, this line here, your x-axis, that's at y equals 0, okay? So that means what we have to do is plug in a 0 for our y. So instead of a y here, we're going to replace it with a 0. So then you get 0 equals ax squared plus bx plus c. Now with some like special manipulation, you can actually derive what's called the quadratic formula. And the quadratic formula says that if you're trying to solve for x and you have something that looks like this, then x always equals negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. So remember, a is the same a throughout, right? So my a that's in front of my x squared is the same a that's right behind the 4, and it's the same a that's right behind the 2. All right? Our b is the same b that's in front of the x. It's also this same b here that's negative b, and it's the same b here that's b squared. And our c, let's do blue. Our c here is the same c that's there. So let's go ahead and break this down a little bit. So we have negative b plus the square root of b squared minus 4 times a times c. So make sure that you are always multiplying those together first. All divided by 2 times a. All right. So you see that this one looks slightly different than our original, and that's because your solutions, right? You should always have 2 solutions. Well, not always, and I'll explain when you won't in another video. All right. But you always have 2 potential solutions. So you have the x equals negative e plus the square root of b squared minus 4 times a times c all over 2a. And you have x equals negative b minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so I just wanted to point out here that this plus minus means that we can split these into 2 separate formulas. We just typically only write it as one formula because most of the steps algebraically are the same. The only step that's not the same is one of our final steps where we either add things together or we subtract them together. All right? So what you're going to be doing today is I'm going to have you identify your A, your B, and your C. All right? So that's going to be what you're going to do for most of your questions today. So I'm going to go ahead, write out a few problems, and they, just like with our review videos, you're going to have a pop-up question. All right? And you're basically going to select your A value, your B value, and your C value. All right? So if we have y equals 6 minus 2x plus 5x squared y equals 3x squared minus 7 plus 4x. And y equals 4x squared minus 7x plus 4x. All right, so those are your 3 problems. By now, you probably have already had them pop up the questions. But that's all you got for today. It's just identifying your A, your B, and your C. We'll work more with this gobbledygook later, but all you're doing today is identifying your A, your B, and your C. Thanks for watching.